This problem involves a device known as an Atwood machine. It reads, two masses, one of mass 1 kilogram and the other of mass 0.8 kilogram, are joined by a massless rope suspended over a massless pulley. Find A, the acceleration of the system, and B, the tension in the cord. Let's first look at the motion that's involved in this. Here is an Atwood machine, two masses tied together by a rope over a pulley. If we release the masses, the 1 kilogram mass accelerates downwards, the 0.8 kilogram mass accelerates upwards. One important thing to realize in this problem is that the magnitudes of these two accelerations would have to be the same. Since the two masses are tied together by a rope, the downward acceleration of the 1 kilogram mass must be equal in magnitude to the upward acceleration experienced by the 0.8 kilogram mass. All right, why don't you try to solve that problem now before watching its solution? Here is a diagram of our problem. I have let the 0.8 kilogram mass be labeled M1, the 1 kilogram mass be labeled M2. M1 accelerates upwards with an acceleration that I've labeled A. M2 accelerates downwards with the same acceleration A, but in the opposite direction. The first thing we want to do here is to draw a free body diagram for each of the masses. On M1, we draw all the forces acting. We have, as usual, the weight acting downwards, M1G. The upward force provided by the rope, let's call that force the tension T. For the mass M2, we also have a weight acting downwards, M2 times G, and an upward force due to the rope on the mass, which we'll also call T. And this tension is exactly the same on M2 as it is on M1. For a massless rope over a massless pulley, the tension in all parts of the rope is exactly the same, and that fact is necessary in solving this problem. We now write Newton's second law for the mass M1. We would write upwards T, downwards negative M1G is equal to M1 times A. Sum of the forces is equal to the mass times the acceleration. Both the tension and the acceleration are unknown in this equation. We do know the mass and G. We cannot solve this equation for either A or T. Let's see if we can find another equation. Writing Newton's second law for mass M2, we would have, again, upwards T, downwards M2G is equal to M2 times A. And I want to be careful here. This acceleration for M2 is downwards, so I'm going to indicate that with a negative sign in front of it. So now we have two equations and two unknowns. We can solve this simultaneously for either one of the unknowns. Let's solve first for A. We're asked for that in part A of our problem. In both equations we have the tension T, and we would like to eliminate that. If we multiply the bottom equation by -1, then each of the terms changes in sign. That becomes negative, positive, and positive. If we then add these two equations, the t's will cancel out. 0 plus m2 minus m1 times g, and on the right, m2 plus m1 times a. If we solve for A then is equal to m2 minus m1 times g, divided by m2 plus m1. And plugging in some values, m2 was 1 kilogram, so the acceleration is 1 kilogram minus 0.8 kilograms divided by 1 kilogram plus 0.8 kilograms times g, 9.8 meters per second. This then in the numerator is 0.2 kilograms, in the denominator 1.8 kilograms times 9.8 meters per second turns out to be 1.09 rounded to 3 significant figures meters per second as the acceleration of our system. So mass m1 accelerates upwards with that acceleration, m2 accelerates downwards. In part B, we're asked for the tension in the cord. We can use either of these equations to find the tension in the cord. Yet let's use the first equation here and solve it for T. Getting a little space, we can then write T is equal to m1g plus m1 times A. That's equal to 0.8 kilograms times 9.8 meters per second plus 0.8 kilograms times A, which was now found to be 1.09 meters per second. If you work that out on your calculator, you should find that the tension then is 8.71 newtons. So that is the answer to part B, the tension in the cord. That is the answer to part B. We have both our answers, so that is the solution to our problem. You could check the answer to part B by solving for T from the second equation, and if you do, I'm sure you will find exactly the same answer that we found by using the first equation. All right, let us move on now to our next problem.